One of the most intriguing planetary bodies of interest to astrobiologists is Europa, one of the moons of Jupiter. Europa is the smallest of Jupiter's Galilean satellites. These are the 4 moons that were discovered by Galileo Galilei in 1610. Europa is slightly smaller than our own moon, just over 3,000 kilometres in diameter. It orbits around Jupiter once every 3.5 days. The moon is tidally locked, and what that means is that one face is always pointing towards Jupiter and one hemisphere is always pointing away. And it feels the gravitational effects of other moons and also Jupiter. These gravitational influences causes the moon to buckle as it's tidally distorted by these immense forces. Most of what we know about Europa is from flyby missions. For example, Pioneer 10 and 11 in 1973 and 1974 took the first close-up images of Europa. And then in 1979, the Voyager 1 and 2 spacecraft, destined to eventually leave the solar system, also took detailed images of the surface of Europa and saw an icy, crusty surface. And this prompted the first discussions on the possibility of a subsurface liquid ocean. The Galileo probe in 1995 took some of the closest and most detailed flyby photographs of the surface of Europa, revealing some of its fine features, revealing cracks and fractures and chaotic terrains that have intrigued scientists since. And in 2007, the New Horizons probe that's destined to reach Pluto in 2014 also took images of the surface of Europa. These images taken by previous spacecraft have allowed us to look at the surface and try and understand the composition of Europa and its internal structure. The surface of Europa is crisscrossed by dark lines. It's a very bright surface and it has very few craters from asteroid and comet impacts, and this suggests that the surface of Europa is very young, at least relatively geologically young, and constantly being resurfaced. One might ask what causes these bands across the surface of Europa, and one theory is that they're caused by warm ice rising underneath the surface of the European crust and causing the crust to break apart and form these lineations across the surface of Europa. Other chaotic terrains that look surprisingly like chunks, if you will, of icebergs moving around, not quite in that way, but they suggest that the surface of Europa is very young and is constantly being reformed. It's not known at the current time how thick the European ice shell is. It could be a few tens of kilometres, it could be hundreds of kilometres. Recent evidence suggests that there may even be liquid water very near the surface of Europa. The fractures that we observe on the surface of Europa are probably created by the force of Jupiter pulling on Europa, its vast gravitational force. We would expect the fractures to form a very predictable pattern if they were just very basic geological features from ice cracking, but they become increasingly different from what we would expect the older they are. And this would make sense if the interior of the planet was rotating faster than the exterior. What that suggests, therefore, is that the core of Europa is detached from the icy surface, and that might be by a liquid water ocean. There's other evidence for a water ocean as well. The saltiness in the ocean perturbs the magnetic field of Jupiter, and this is evidence that's been picked up by studying Jupiter's magnetic field around Europa. This type of evidence also suggests that Europa has a salty ocean inside it. When we put all this evidence together, what we find is a model that might look something like this. The inside of Europa may have a metallic core surrounded by a silicate mantle, a mantle essentially of rocks, and then a liquid ocean over that core, and then finally a solid icy crust on the surface, which is what we see with orbiting spacecraft. Now, of course, the question for astrobiologists, the most intriguing question, is could there be anything living in the European ocean? The possibility of liquid water has made Europa one of the main targets in the search for extraterrestrial life, and it's possible that life inside Europa might look something like we observe in deep ocean vents at the bottom of the Earth's oceans. Of course, we don't really know what the chemistry is inside the European ocean, and we don't know what the conditions are on the surface of that silicate core at the bottom of the oceans. It may not look anything like the deep subsurface of Earth's oceans, but by looking at life in deep crustal materials on the Earth, we might get some ideas of the sort of life that we might at least look for inside a European ocean. There has been some controversial work suggesting that radiation hitting the icy surface of Europa could produce free oxygen, which could seep down into the ocean, and some people have even speculated on the possibility of complex life inside the oceans of Europa, feeding off this oxygen and gaining energy from the respiration of oxygen with other compounds. Well, of course, all of these speculations are very interesting. They certainly fire the imagination of astrobiologists and the public alike, but we need to know much more about the chemistry of the European Ocean in order to assess the habitability of this planet. Future missions have already been planned to take a closer look at Europa and Jupiter's other moons. The Jupiter Icy Moon Explorer JUICE, which is being developed by the European Space Agency, will explore Jupiter's moons and take a closer look at Europa. Here is a fanciful image showing a possible mission to explore the oceans of Europa. In this case, the craft has melted its way through the European ice sheet and has sent out a small probe to explore the bottom of Europa's oceans. These, of course, would be extremely challenging missions to implement technically, but they show you some visions of the possible astrobiological future of the exploration of this fascinating moon. So what have we learned in this lecture? Well, hopefully we've learned that Europa is a moon of Jupiter, which is a good candidate for life, or at least exploring potential habitability. Most of our knowledge of the moon is from flyby missions. The surface of Europa is young, it's icy, and it's actively deforming. And Europa gains its heat from tidal interactions that cause the buckling of the moon, generating heat and thus melting that ice and contributing to the formation of that deep European Ocean. There may be a liquid water ocean under the ice, and further investigation will determine if anything lives in this subsurface ocean. So we can see that Europa is an example of a moon with a subsurface icy ocean of great interest to astrobiologists and future exploration.